In this lesson we're going to look at two more examples on indefinite integrals. So example 10, so we've already done a good few examples so far, and for example 10 we want to find the integral of t multiplied by t plus 3 with respect to t. Now again, hopefully you'll realise that we can't at the moment integrate something with brackets, so we need to expand these brackets. So what we're looking to integrate is t squared plus 3t with respect to t. Carrying out our integration here, we'll get t cubed over 3 plus 3t squared all over 2 plus our constant of integration, which is our final answer. We can't simplify that any further. Now example 11 is on the next slide, so just now would be a good time to pause the video and copy this one down. Welcome back folks, and we'll look at example 11 now. We want to find the integral of 4m squared minus m plus 7 all over the square root of m with respect to m. So we need to remember that we've got a single fraction here, and before that became a single fraction, it was a sum of fractions with a common denominator here. So we've got 4m squared over root m minus m over root m plus 7 over root m. And we're integrating all of that with respect to m. Now it's still not ready for integration. We can see that the denominators, the square root of m, can be expressed as m to the power of half, and our 4m squared over m to the half here will become 4m to the 1.5, that's 3 over 2. Here we've got m over m to the power of half, and that's m to the 1 over m to the half, so that leaves us with negative m to the half, and then we're adding on 7 over m to the half, so that's 7m to the negative a half. So we're now ready to integrate this. We've prepared it for calculus, and when we integrate, remember we are adding 1 to the power and then dividing by that new power. So we get 4m to the 5 halves all over 5 halves, minus m to the power 3 over 2 all over 3 halves, plus 7m to the half all over a half, plus our constant of integration. Now remember here, dividing by 5 over 2 is the same as multiplying by 2/5, so that leaves us with 8/5 m to the 5 over 2. The second term, dividing by 3 over 2, is the same as multiplying by 2/3. And dividing by a half is the same as multiplying by 2. So we can see there we've now got 8m to the 5 over 2 all over 5 minus 2m to the 3 over 2 all over 3 plus 14m to the half all over 1 plus c. And we can now express these terms with radical signs because we've got fractional indices here. So we get 8 times the root of m to the power 5 all over 5 minus 2 times the square root of m cubed all over 3 plus 14 times the square root of m plus c, and that is our final answer. So you need to make sure your indices here are up to scratch, and that you're able to manipulate this algebra before trying to integrate anything. So just now, before the screen goes blank, pause the video and take this note down in your notes and make sure you complete the assigned exercise for today.